Hi guys, and welcome to my channel. In today's video, I'm going to show you how to build your first machine learning model using the SkLearn library and New York transportation dataset of the number of bikes or bicycles that cross New York bridges per day, and we're going to implement it in Python. So stay tuned. Okay, for the purpose of this tutorial, I'm gonna go over the article or the blog that I wrote about about how you can create your first linear regression model using SkLearn and Python. And through it, I'm gonna explain as well what do we mean by linear regression and its use cases and how you can get started. Okay, so let me first share my screen and provide you with some background information about linear regression before we go into the code. Okay. All right. Okay, so this is a blog that I wrote about how to build your first machine learning model in Python, and it's on Medium. I recommend you guys go and follow me there because I write I'm posting blogs over there if you want to come back to the video, to what I mentioned in the videos, but you want to read it without watching the video, you can go there. Okay, so guys, okay, so linear regression. What do we mean by linear regression? First of all, in my introduction to machine learning, I mentioned to you guys that we have two types of machine learning, supervised learning and unsupervised learning. And I said that supervised learning, we're training the model knowing the answers, which means that I already have in my data set the output that I want to generate and the result that I want the model to give me. So I'm not inventing the output, I already have it. I just want to teach the model how to obtain it or how to derive it on its own. So we have, in other words, what we have is labeled data. Okay, so in supervised learning itself, there are two types of models or like problem types. We have a classification and regression. Classification when the output is a category, and regression when the output is a quantity. So it's easy. Classification, we are predicting yes or no, white or black, it's gonna rain or not, he's gonna vote or not. So, or maybe three options like red, blue, yellow. Okay, so multi-class or binary class. In regression, the output is a continuous numerical value. So the output is a number. We're predicting a quantity. Maybe the soccer game, the score, maybe the height of a player, maybe the temperature, or in a certain country or place, and the list goes on. Okay, so in simple words, supervised learning revolves around utilizing past data to predict future data, and if what we are predicting is a class, meaning yes or no, male or female or whatever, then it's a classification problem. If what we are predicting is a numerical value, then it is a regression problem. In today's video, we're going to implement linear regression, meaning we are going to predict a continuous number, and we're going to fit a linear function into the data. What do we mean by that? Before going into the meaning of linear regression, let's just go over the business problem that we're going to solve today. This way, you can imagine it's easier to understand the concept with an example. Okay, so for the sake of the data, for the sake of this video, we're gonna have this problem. It is like the question, the business problem question is, how many bicycles per day cross New York City bridges in total, given the weather conditions on that day? Okay, so it's an easy question. Give me the total of number of bikes that you expect per day, to cross Brooklyn Bridge or to cross Williamsburg Bridge. Okay, what input we have? We have the temperature, the high, the low, and we have the chances of rain or not. Okay, so in other words, predict the total number or the total count of bikes that cross over bridges per day. Okay, so the total or the count is a continuous number, so it's a regression problem, and what we're gonna say it is a linear regression. It's a linear regression problem. Okay, now the data that we have is it was obtained from New York City transportation, and I got it from Kaggle. I recommend you guys go and create an account on Kaggle, and you can see tons of data sets, problems, and you can go over different examples and how to solve them and so on. Okay, in the data we have collect the daily count about the number of bicycles going over bridges in New York, and we have, as I said, the weather, the weather data, what's the high temperature on that day and so on. I believe I have an example of the data over here. Okay, I'm going to show you guys how you can print this out as well. Okay, so this is an example of the data. Let's say the date 2016, April 4th, 1st of April. And we have the high temperature as 78, the low 66, the chances of rain 0.1, and how many bikes cross Brooklyn Bridge on that day, how many bikes cross Manhattan Bridge on that day, and how many bikes are crossing Williamsburg Bridge on that day, and the total per that day. Okay, so this is an example of labeled data. What do we mean by that? It means that on this day, on this row, this instance, this data point, we know what's the total is. Okay, so we know how many bikes are gonna cross the bridge. Okay, this is the value that we're trying to predict, the total. Okay, so without further ado, let me before moving into the code, let's just again explain exactly how linear regression works, so that you know the math behind the functions, and you know how to interpret and how to understand the results. Okay, so linear regression is a very commonly used supervised learning algorithm, and we are trying to figure out the relationship between x's, which are the input variables, and the output. What do we mean by that? It means if we look at our data, we want to figure out the relationship between the temperature, the weather conditions, and the output, the total number of bikes that are going to cross Brooklyn, the NY bridges. Okay, so we're trying to figure out the relationship between x input variables and y, which is the target or the output. Okay, it's usually either a univariate function, meaning that I have a single independent and dependent variables, or a multivariate case in which we have more than one independent variables. What do I mean? What do I mean by that? I mean the variables, like in our example here below, we have more than one variable that affects the total number of bikes that's going to cross the bridges. If we had only, let's say, one variable, it was going to be only one column. So let's say only temperature, no low temperature, no precipitation, and no whatever. Okay. So what we're trying to do is to fit a line here, okay, between that mostly represents the data points that I have. So I'm trying to fit to find the best fit line, okay, such that it would find the correlation between the dependent variables, the y's, and the independent variables, the x. All right, so each point here represents a data point in my data set, and I'm trying to fit a line, which we refer to as the line of regression, into these data points, such that I figure out the hidden relationship between the independent variables and the dependent variables. All right, so if we want to write it in math, it's going to be output y equal a plus bx, and basically y is the output variable and x is the input variable. Okay. Also, guys, in data science terms, in machine learning terms, usually the function that we're trying to predict is called the hypothesis, and it's referred to as h, and the parameters that affect the line, the slope and the intercept, are referred to as theta 0 and theta 1. Okay, this relationship goes for the single or a univariate the linear regression model. We also can have a multivariate model in which we have more than theta 1. We would have theta 2, and we would have x2 as well. That is called another variable which would affect my output or the target that I'm trying to predict. Okay, so let's now move to the implementation of the model. Basically, let me just guys share with you the okay, sorry. Okay, for those of you guys who don't know this interface, it's called Jupyter Notebook, and it's basically a way that you can run your code and get a result without installing any environment on your machine. Like, you just basically using your command line, you would open it, run Jupyter Notebook, and start compiling, and you can change the language as you like, and you can save it and so on. I recommend you guys read into it, or if you're interested, I can make a video on how to run this, and but that's a different topic. Okay, all right, so first of all, what we need to do is to import the libraries that we're going to use. Okay, basically, guys, there are commonly used libraries, and especially for data processing, like two most famous ones are Pandas and Numpy. They have many good methods that you can make use of. Okay, so let's go ahead and import them. So import Pandas as PD, and let's import Numpy as NP. Basically, here we're gonna import the needed libraries for data processing. Okay, and we're gonna need for plotting we're gonna now need a method, a library called matplotlib, and it's a very commonly used one, and another one called SkLearn, which is good for heat maps. So import matplotlib.pyplot as plt and we import SkLearn as CNS. Now let's go to the libraries that we're going to use for machine learning. I'm going to also show you down when we start doing the notes where we can add them as well. So from machine learning libraries, we're going to import from scikit-learn.module selection import test split. This is a library that we're going to use to prepare the training and the test data. And from scikit-learn.linear module import linear regression. And also for the evaluation, we're going to import scikit-learn import. Okay, this is what we're going to use for the evaluation. Now, that's for the imports. So let's go ahead and run it. Oh, sorry. Where is the error? From Pandas import. Yeah, this one. Sorry. Okay. That's for the imports. Now let's go ahead and read our data. So our data that we're going to use, as I said, it's the NY transportation results, and for the number of bikes that cross the bridges per day. So I already have downloaded it locally on my machine. So I'm gonna just read it. To read the data CSV, Pandas has a very commonly used data frame, and it's good with reading CSV files. So we're gonna go ahead and use it. So data frame equal pandas.read CSV, and then this path will be different for you. So this is the path that I already have my my data saved at. So let's go ahead and copy the path. Sorry. Here is the path. Downloads NY C East River bicycle counts, and also let's set the parameter car states equal to true, and let's set the index to our red data frame as the column date. So what was it called? Date. Yeah. This means that my red CSV would have this as the column. And let's go ahead and print it. This is the data. Okay, guys. So I have each row is the index. The index column is the date. Okay, and these are the already the features that I have in my data, and the count of the number of bikes that crossed each bridge, Brooklyn Bridge, Manhattan Bridge, and so on, and the total count, which is a sum of them. Okay, and okay, if you note what actually affects the total, it's only these three. So the temperature, the high and the low, and the precipitation. Okay, now let's go ahead and explore the data. There is a method, a very commonly used method usually in like when you do explanatory data analysis. It's called this describe, and basically, guys, this method would give you the like some stat values about the data. So data frame to describe will give me what? The count, the mean, the standard deviation, the min, the 25th percentile, the 50th percentile, and the max values. Okay, for each column in the data set. This is good when you don't know anything about the data and you want to get some numbers to understand what's happening in them and to make use of what you already have, like without any machine learning. You just want to like explore the data, basically. Okay, and also, guys, here you can see the how many rows and columns we have in the data. So it's a 2010 by 10 columns. And also there's a method if you don't there's an attribute in Pandas, and basically for data frames, and you can use it like this. So this would return for you the shape of the data frame, how many rows per columns are in the data frame. Okay, and as for the type of data, you can also per column you can get it by dataframe.d types. Okay, this way you will also get the what is the content type per each column. So the day is an object, the temperature is a float, the precipitation is an object, the Brooklyn Bridge and all of that, they are float and int, the total is an int. Okay, now as I said, the thing that makes like affects my total is are these three columns. Okay, but two of them are floats and one is object. We need to convert this object into an integer or numerical value, because we can't use data type as object to feed it into machine learning model. All right, so how we do that? Very simple. Basically, we call the column per situation. We want to update the value inside of it, so we do like this. Okay, and then what do we want to do? We want to replace what? Now let's take a look over here before we do it. If you take a look here, the precipitation at this column, you would see that on this day we have like this value. Okay, but like in all other days you would have what? A float value. Like it's an object, but it's the type, like inside of it, it's a float. Okay, we want to get rid of this s. Okay, and also if you download the CSV file and you go over all the column, all the rows, you would see that there's also another instance where they have the letter T. Okay, so we want to replace these two, this and the letter T, with their float or numerical format. Then we can convert the whole type of the column into float. Okay, so we want to replace the, just 1 second. Okay, so we want to replace, hey mama, we want to replace the 0.4s here with this. We want to replace it with 0.47. Okay, and we want to do the same. Let me make this bigger for you. We want to do the same for the T. So we have a T here. Now let's replace it with 0. I'm gonna replace the T with a 0. Okay, so That's it. Now let's replace the whole type of the column with the .s type method. So we can do this by doing data frame .s type. And what do we want to make it? We want to make it float. Let's run that. Now we have the precipitation type as float. Let's also do one thing. If we don't save it, it will just only print it out, but we keep the old values. So let's just save it inside the column itself. Now, if we take a look at data frames, the types, we would get type of float. Okay. Now, this we did, like, we're just fixing some stuff about the data to make it into numerical format so that we can use it later into the machine learning model training. Now, there's a very useful method called correlation, and basically it finds the pairwise correlation between all like columns in the data. And this is important because we want to see how the columns values are against each other, like if there is any hidden correlation, or if there is any hidden relationship, if they are positively correlated or if they are negatively correlated. This method will calculate that for us. So we can just say for a data frame .correlation, and we will get the correlation between the columns. Take a look with me, guys, over here for a second. Okay, let's take a look at here. Okay, take a look at the total. Okay, the total is very important for us. That's what we're trying to calculate. See how the total is related to the high temperature. Okay, what's the correlation between the high temperature and the total? Okay, you can see that the value is 0.7433. This means that they are positively correlated, and if there's a high temperature, you'd see increased number of bikes that cross the bridges, which makes sense. Now, look at the precipitation and the total. You would see a negative sign and this value. This means that the sign means that the total column and this variable, they are negatively correlated. So when the chances of rain are high, less people are going with bikes over the bridges. We can also, there's a nice way to visualize it using the SkLearn heat map. This will give you like we can view the heat map of the correlation matrix using the SkLearn library. You can just simply write like this, guys. Correlation equal data frame dot correlation as we wrote before. Then the heat map. Sorry. Dot heat map, and you pass the correlation, and you want to set the x-ticks labels as the correlation dot columns values. And you want to do the same for the y labels, the y ticks. Okay, and the last thing we need to do is to set the annotation as true. Okay, and it's closed. Now let's view it. as you can see, the negative correlation between the total and the participation. Okay, so negative 0.6, negative 0.59, and so on. Okay, so let's move now to the machine learning part. All of what we did above are is data analysis and pre-processing, and of course for each different project you would need different pre-processing step. We just here did a couple of stuff, very basic, very abstract stuff to understand the data. All right, first thing, it's almost like ABCD. You have to prepare the X data. What is the X data in our case? Yeah, it is this, right? The high temperature, the low temperature, the precipitation. So we basically just write it down here into a list of. Let's just copy it instead of writing it down. So high temperature and low temperature and the precipitation. Okay, this is the X data, and you can see that when we do that, if you want to print it out, that's X data. And now for the Y data, is what data frame, and what's our target? It's the total. So we'll do that for the Y data. Okay, if you want to visualize it, you can visualize it like this. Okay. Yeah, that's my little girl. Sorry, guys. Okay, now let's this is the whole amount of my X data and my Y data. Usually, you wanna split that into training set and testing set. What do we mean by test set? Test set is after you train your model, you wanna check or evaluate how it performs on unseen data. So you use the test data. So you don't use the whole data for training. You take a small portion of it and keep it on the side to do the testing. So how we do that? Using the test split from SkLearn import. So what do? We basically do X train and X test, Y train, and Y test. Okay, and we will make it equal to train, test, split, and we pass what? We pass the X data and we pass the Y data, and we set what? The random state, and this is, guys, it as equal to 1. This number, guys, indicates where the split is going to happen in the X data, the whole data. So if you don't set it, if you run it without setting it, each time you run the code, it would split it differently. So you would lose your you will not have the same data in future runs. Okay. So this way with this we prepare our data. Okay. Now if you the next thing you have to do after you prepare, so you prepare test and train. Now let's go and initialize the model, create the model, and fit it. We do so using what? We already imported it, linear regression. Okay, so we just simply say linear regression module equals to linear regression. Okay, and then the output would be what? Equal to the model dot fit. And what would I pass into it? The X train and the Y train. And the Y train. And basically with this step we fitted the model, we are training the model. And so here is the training happening. Okay, now let's see. So we run it. Okay, now to predict, what do we write? We write y predict. So prediction happens like y predict equals to linear model dot using the method dot predict, and we pass the X test data, and basically I would be predicting the y. So that's how it is, guys. So these are the y outputs, which is the predicted number of bikes for the X test rows. So the results, like how many number of bikes for this X test. Okay, now to evaluate the model, for evaluation there are like tons of not tons actually, there's a couple of metrics for regression methods, and in our scenario we just use the mean squared error. Okay, and we can use that. We can just simply write it like this. So matrix dot mean. We already imported the matrix here, guys. Keep in mind that we already imported it here. So matrix dot mean squared error, and we pass what, guys? We pass the y, the y test. So the actual results, like the actual true data for the predicted output, and what we predicted. So here, this is what the model is saying that we're going to have as the total number of bikes. Here is already what the data have. So the actual and the predicted, and to calculate the square root, we just say numpy dot square root, and we close it like this. Okay, and that's the number we get. If we don't use the square root, it's going to be a huge number. Okay, there's a lot of there's many stuff that we can do. This is very basic, but we basically, what we did, to recap, we prepared the data, the X and the Y, the X data and the Y data. We did the split, the X train and the Y train, the X test, the Y and the X test and the Y test, and we created the model. We fitted the model with the data, and then we predicted the output. Also, we evaluated the output. There's much more that we'll cover in other videos in the future. Thanks a lot for watching and for tuning in, and I hope, guys, you understood more what is linear regression, and that you created your first linear regression model. Thank you, and see you in next videos.